Good morning, class. So let's get started with using the unit circle, unit 5, lesson 3. Question 1 says, predict whether each value will be positive or negative. Explain the meaning of each ratio. So it's important that you know, one, to know how to use a calculator in this and to verify or to actually get the value, which is often not exact. Meanwhile, also being able to interpret what's going on, and that's why we're going through this prediction method. So for tan 195, I'm going to start off by drawing the x and y axis. And so recall that we have 0 degrees, 90 degrees, 180, 270 degrees. And based on that, where this is the initial position, you're going to draw your angle roughly, but making sure it is in the correct quadrant, and that's the most important part. So it's not in quadrant 2 or 1, but it's going to be in quadrant 3 because it's a value higher than 180 but less than 270. So because this is 195 degrees, that makes this related acute angle, which is always to the x-axis, 15 degrees. I habitually write cast to tell me the signs of the primary trig ratios. And I've been using these highlighters to help you visualize where tan is positive. Well, tan is positive here because that's where all the trig ratios are positive, and tan is positive there. Based on this information, because our angle lies in this quadrant 3, then the answer to this question is that tan 195 is positive. And then I need to go about writing down what this means. So remember for tangent is when you have y over x. It's the slope. And notice how this is a slope, and slope is going left to right, it is going up. Therefore, it is positive. That's also another way you can interpret it. So tangent is slope of the terminal arm. Let's go to question B. So sine negative 115 degrees, again, I'm going to draw my x and y axis. And while these parts are 0, 90 degrees, 180, and 270 degrees, and then this is as well 360 degrees, from the initial position, instead of going counterclockwise, and that is the positive degree, if I was to just draw it in order, I would probably draw it so that my terminal arm is here. Well, how did I arrive at that? Well, that's because, from here to here, that's negative 90 degrees, and from here to there, that is negative 115 degrees. By the way you can interpret it is that, from here to here, that is the principal arm. I would simply do negative 115 plus 360, and that is equal to 245 degrees. Meanwhile, another relative information is the related acute angle. And how do I find that value? It's going to be the easiest if I interpret it as saying 180 minus 115, and that is equal to 65 degrees. So again, rather than memorizing whether you add or subtract based on what, try to look at the full picture. And if from here to here is 115 degrees, then this is 65 degrees. And we always write the related acute angle as 65. By the way, this is just FYI side info, and I didn't really need that for this question itself. Gonna write cast here again and then interpret it in this case. So I'm thinking of this in my head, but I'm just highlighting it for you so you know what I'm getting at. Is that because my terminal arm is over here on the bottom, and that means my sine ratio is positive when it is in the blue category, because this is where sine and all trig ratios are positive. But because my terminal arm falls in this part of the quadrant, I'm going to say that the answer to this is going to be a negative. The sine is the y value if, let's say, the radius is equal to 1, and that is according to the triangle we drew earlier in the previous lesson, like so. So sine theta is equal to y, right? And so going back, that means that we have sine is the y coordinate, and it's below the origin. And how did I know that? It's because it's right over here, below the origin. So let's go on to question C, cos 670. So first I'll draw my x and y axis. But before I start, well, cos 670, it's hard to interpret what that means. So that just means that there was a full one rotation within that. And so in my head, I'm going to do 670 minus 360, which is equal to 310. So another version of this is cos 310. And they're like the exact same thing, but I'm dealing with it so that I'm dealing with the coterminal version. And this is going to be a lot easier to work with because it's within the domain of 0 degrees to 360 degrees. And I got this by doing minus 360 degrees. Okay, moving on, cos 310 is obviously a lot easier to picture on the x and y axis. So my 310 degrees is in, and this is how I'm going to draw it out. This from here to here is 310 degrees. Again, extra info that I don't need right now is that this part is 50 degrees. CAS rule. So this is the CAS rule, and now I'm dealing with cosine, and that's why I'm highlighting these two. These are where my cosine is positive. And look, my terminal arm is where I've indicated that cosine is positive, and therefore my cos 670 should be a positive. For any of these three questions, you could have used a calculator to double check and say tan 195 equals. And when you do that, you get a value of, let's say, 0.2679, a positive number. Okay? Let's move on to question 2. For all the above, state an equivalent trigonometric expression with the same value of the ratio. So let's deal with a tan 195 degrees. So when I take a look at tan 195, it has a related acute angle of 15 degrees. This is the part that's helpful. Recall from the previous lessons that my sine 160, sine 200, my sine 20, sine 340 all gave me the exact same magnitude but different signs. I could use that idea. So as long as I'm working with the related acute angle, I just have to properly state the sign and go from there. So let's work this question out. So I took a screenshot of the above image and I'm working with that. So the easiest first angle that I'm going to indicate is 15 degrees. Well, why is that? If tan 195 is this value, tan 15 will also be the exact same value, and it will be the same sign because according to my highlights. And my highlight indicates where my tan ratios are positive. And so that's why I can just write tan 195 is exactly equal to tan 15, which is in quadrant 1. Okay, let's keep going. So basically, I can continue to draw my new terminal arms. And if that is the next one, well, I'm going to make sure that it has a related acute angle of 15 degrees. Or, well, how do I get this angle? I'm going to do 180 minus 15 degrees to get that. And that is equal to 165 degrees. So I'm going to write down as the next part as equals to tan 165 degrees, which is in quadrant 2. But I can't leave it that way because my tan ratios are not positive over here or here. So that means all I have to do to change this is that I'm going to put a negative in front of that. So you're going to work from the initial arm, so not there, but the initial arm and do 360 minus 15. How am I getting that? Well, a full circle is 360 degrees. And if you take away 15, you get 345. And you're going to say equals to tan 345 degrees, and it's in quadrant 4. And I have to put a negative in front of that whole thing because, again, it's in the quadrant where it is negative. And so I need to put another negative sign in front so that the numbers are equal. And in case you need to visually see this, tan 195 is equal to 0.2679. And 15 is also 0.2679. And then negative tan 165 is equal to 0.2679. And negative tan 345 is equal to 0.2679. Through this, and you have verified that all these values are equal, and that's why you're able to state it like so. It looks too busy, so I'm going to erase that part. Okay, so at this point, let's try to do question B. And we have sine negative 115, and I'm not going to keep drawing the drawing again, but refer to my original. So if I have sine negative 115, and this is my angle, and I need to come up with another trigonometric ratio. Well, if I was to go in order, that means that if I have an angle right here, that means I would have a related acute angle right here with a 6 sine, so I could write sine 65. However, because my sine is positive over here in quadrant 1 and 2, but it is negative in quadrant 3 and 4. To make this work, I need to put a negative sign in front of this trig ratio so that it is equivalent. Moving on to the second one, if I'm going in order again, I have another angle over here, and if the related acute angle is 65 degrees, well, in my head I'm doing 180 minus 65 degrees, which is equal to sine 15 degrees, sine 115 degrees, and that's in quadrant 2. Again, you should be noticing that this is where my sign is positive, but mine is supposed to be negative, and so to make up for that, I'm going to put a negative sign in front of sine 115 to make those equivalent. Moving on to the next one, we have our original. Well, with our original, the principal angle version of it is that it's sine 245. So what I'm doing is 360 minus 115 degrees, and I get 245. So I'm going to write sine 245 degrees, which is in quadrant 3. Lastly, if you have quadrant 4, if you have an angle over here, well, if the related acute angle is 65 degrees, but my terminal arm is over there, that means I have to do 360 minus 65 in my head and use a calculator, and you get sine 295 in that case. So how did I get that? I did 360 minus 65, and that is in quadrant 4. Let's move on to C. So if we have cos 670, and let's go in order again. So we have cos 670, and if I'm going to go from quadrant 1 to quadrant 4, well, my related acute angle right away is 50 degrees because I wrote that earlier. And if I wanted in quadrant 1, which is over here, I would draw that out, and I would get cos 50 degrees. But noticing that actually my cosine will be positive in these quadrants, I could write down cos 50 degrees. And that's in quadrant 1, and I don't need to change a sign because my signs will work out. On to the next one. If I go to my quadrant 2 and I imagine drawing my angle here, well, my related acute angle is 50 degrees, and so I'm doing 180 minus 50 degrees, and that is equal to 130. So first let me write cos 130 degrees, and that's in quadrant 2. But meanwhile, my cosine is negative over here, right? And so then I need to put a negative in front of my whole trig ratio to make up for it so that cos 670 degrees does equal negative cos 130 degrees. I'm going to go to my quadrant 3. So if I have an angle here with a related acute angle of 30 degrees, that means that I have to do 180 plus 30 degrees to get that. And so 180 plus 30 is equal to 210. So cos 210 is in quadrant 3. And I'm going to put a negative sign in front of the whole thing because of the same reason as above. And lastly, we have the final angle. Originally, I wrote cos 670, but Remember, a coterminal version of that is cos 310, and that is within my 0 degrees to 360 degrees, and therefore I have cos 310 degrees. Do I need to change the sign? No, I don't, because that is my original terminal arm, just saying it in a different way, and that is in quadrant 4. Okay, let's go on to question 3. Find the following ratios without using the calculator. When they say that, go through it algebraically and then use a calculator to double check, okay? Just because I say don't use a calculator, it just means you have to show your work to get to your answer. Make sure you show your progress and then verify using a calculator, okay? So when I have cos negative 90 degrees, keep in mind that is a quadrilateral angle. And what that means is that it falls on the x or y axis. Instead of having an angle that falls in between, but you're going to have an angle that falls exactly on the x or y axis. And if you look at those angles, a negative 90, 180 degrees, 270, 360, those are all quadrilateral angles. So for cos negative 90 degrees, to figure out this without using a calculator, and sometimes I prefer not to use a calculator for some of these options, is to draw out your x or y axis. X and y axis. Draw my circle with my fancy app. Make sure that you're drawing it so that the center is at the origin. So you would draw it so that you have a coordinate at each of the axes, and because this is our first one, I'm going to write down all the coordinates. So 1, 0, 0, 1, negative 1, comma 0, comma negative 1. Okay, at this point, we are dealing with negative 90 degrees, and so from our initial arm, which is over here, we are going to work clockwise to arrive at negative 90 degrees. So we are primarily dealing with this coordinate. And this coordinate has an x value of 0 and a y value of negative 1. Let's go back to the question. So keep in mind when you're dealing with cos theta or cos, according to my SOHCAHTOA and how it applies on the x and y axis, cos theta is equal to x over radius. And that is based on this summary that we had from page 5 in one of the earlier lessons. So back to this, it's equal to x over r, so I'm going to plug it in. So I have x as 0 and my radius, well, my radius value has to be 1 because the radius of my circle is 1 according to this unit circle that I've drawn. And so I have figured out using the unit circle that the value for cos negative 90 degrees is equal to 0, and I was able to break it down based on this. And on the calculator, when you put that in, you will get equal to 0. But again, you have to show your work on how you arrived at that. B, for cos 180, draw the x and y axis and a perfect circle centered at the origin. So now I'm just going to focus on one part. Okay, so we have cos 180 degrees. That means my coordinate is here. And my coordinate is going to be, well, went left 1, so negative 1. It didn't go up or down, so it's negative 1, comma 0. This is my x, this is my y. This is the coordinate that I'm interested in. So cos again, so that is equal to x over r. I'm going to plug in what I know again. Let me pull back for a second. So if this was my terminal arm, this was 180 degrees. Plugging it back in, I have an x value of negative 1. My radius again is 1. Look at the unit circle, it has a radius of 1. Remember, radius value is always a positive value, and therefore you can indicate that cos 180 is equal to negative 1. 270. Draw my x and y axis, a circle, centered at the origin. Tan 270, that means I have to go like so. This is 0, 90, 180, 270. This is where my coordinate is. My coordinate is 0, comma, -1, because it went down to -1. My principal arm, or my terminal arm, is going to look like so. And this is 270 degrees. Reminder from previous part that tan 270 is dealing with the slope. And it's y over x. And look how it's a vertical line. And what do you remember about a vertical line? There was some info about vertical lines and horizontal lines from grade 9. What are the slopes of vertical or horizontal lines? So a vertical line has a slope that is undefined. So this is how it should look like. But let's plug in what we know. So our y value is equal to -1. My x value is equal to 0. And please don't write this as 0, because you need to put in your calculator, okay? And when you do that, any number divided by 0 is equal to undefined. And so things are hopefully making sense. A vertical line has a slope that is undefined. And yeah, and if you do -1 divided by 0, you get undefined again. And so slope of vertical line. And so on your calculator, when you do tan 270, you'll get a math error. And this is one way to look at it. Question D, sine 360, x and y axis, circle, center at the origin. When you're dealing with sine 360, that means your terminal arm is over here with a coordinate of 1, 0. And this is your x, this is your y. So I'm going to plug in things that I know. So for sine, you have y divided by r. And so when you plug it in, y is equal to 0, radius is equal to 1, and therefore the sine value of 360 is 0. And again, this is my terminal arm of 360 degrees. So for question 4, it says find the angles without using the calculator. So over here, I wrote a little summary of what sine theta is in terms of y and radius, cos theta in terms of x and r, and tan theta is based on y over x, and that's from the previous lesson, so that I don't have to go back and forth and you know what I'm referring to. So for cos theta is equal to -1, we need to calculate this without a calculator, and it should actually say that the domain is between theta to 0 degrees to 360 degrees, because if they don't tell you that, you could technically give me like any coterminal arm and it would be true. It can be true. And so I need to kind of tell you what the domain is, so I'm not getting a bunch of answers, but only the ones within the domain. So cos theta is equal to -1. And so I'm going to put this with the radius of 1, because when you have a number and there's no denominator, any number has the denominator of 1. And so this is the x and this is the r, and that's based on my summary. So I can go straight to my unit circle, but in case you need to see this, recall that for a unit circle, or it doesn't really, x squared plus y squared equals r squared. So this is my side notes. Since you have -1 squared for the x squared, and then y squared equals 1 squared, because r is equal to 1, I have 1 plus y squared equals 1. And if I move that 1 over to the other side, that means y squared is equal to 0. And if I square root both sides, I get y equals 0. So just showing you why y is equal to 0 when I start drawing my unit circle. So x and y axis, and so I'm going to break it down. So my x value is -1, And if you look at your unit circle, there's only one spot where it could be a -1. So I'm going to put a -1. And for my y, it's according to my side notes that y is equal to 0. That's the only way it'll work, at least for my when I'm dealing with it as a unit circle. And from there, I'm going to interpret what this terminal arm is equal to. And this terminal arm would have gone 180 degrees from the initial arm. And so you're going to say that therefore theta is equal to 180 degrees. So basically you're trying to come up with a terminal arm that makes sense with your situation to try to find out your theta. You'll see in the other questions that sometimes there's more than one coordinate that works, and that's why the drawing really helps. Let's go to B. B is cos theta is equal to 0. Again, it has a denominator of 1. According to my summary, recalling summary, my 0 is equal to x, and this is the denominator is equal to r. Okay, so I'm gonna draw my x and y axis, circle, centered at the origin. So when I start drawing it out, let's see, we have x value of 0. That means right there. Oh, but also there. So I'm gonna draw two coordinates over here and over there. And my x value will be 0, and my y has to be a 1. And my y value will be a -1 as well. And perhaps you can go through it algebraically like this to have figured it out as well, but I like looking at the visual. Okay, so that means we have a terminal arm over here and over there. That means one of your angles is 90 degrees and the other angle is 270 degrees. So you have two answers for this. And therefore, you're going to have, as theta 1, you have 90 degrees. And for theta 2, you have 270 degrees. Can you please make sure that it looks like a subscript and it doesn't look like an exponent? It's bad form. If you're suddenly writing theta with an exponent 2 or exponent 1, those are subscripts that help me specify what angle I'm referring to. Answers. And I'm putting this in a box to really clearly indicate that, but keep in mind that all these angles do have coterminal arms. Coterminal angles, such as I could have subtracted 360 from that and I get -270 degrees, and there's a bunch. And for this one, I could have subtracted 360 degrees again and gotten -90 degrees, or I could have added 360, right? So these are all coterminal angles that are possible, and that's why at the beginning, that's why I needed to indicate the domain to make this question work. So let me give you a little perspective. Let's say you try to calculate this using a calculator. And so you would have done cos inverse on both sides and you would have gotten theta, right? And so on my calculator, I get 90 degrees when I do that. So keep in mind, the calculator won't tell you the other angle, 270 degrees. That's part of the reason why we need to be able to do it without the calculator, because the calculator is great and all and for verifying purposes and a lot of reasons, but that drawing helps us confirm that there's actually another theta involved. Sine theta is equal to 1, so question C. Here of 1, this is the y and this is the r based on the summary. Draw my x and y axis with the unit circle. We have a y value of 1. That means there's only really one spot where this goes. And that coordinate is equal to 0, 1, just based on where the coordinate is. This is my principal angle. My angle has to be 90 degrees. There's not really another situation where you have another theta within that domain. So you would state that theta is equal to 90 degrees. Tan theta is equal to undefined. So that's where you have to really understand what's going on algebraically. Well, when can you ever have undefined? Well, one situation where that is if you have a number divided by a 0. And we'll say this is y and this is x based on our previous summary. So when I start drawing out my coordinate and try to find my angles, if my x value is 0, that means I have a coordinate here as well as over here. And my terminal arms are going to be over here and over there. And so one of them is going to be 90 degrees and the other one's going to be 270 degrees. And therefore, theta 1 is equal to 90 degrees and theta 2 is equal to 270 degrees. So for question 5 of the next page, we have sine theta is equal to negative 2 over 5. The angle theta is in standard position, meaning that's another way of saying the angles are going to be between 0 to 360 degrees. So I often don't like it when the negative is in front of the fraction sign, but keep in mind that negative can be moved around so that it belongs to the numerator or belongs to the denominator, where we usually say that if it's in the denominator, it's kind of bad form. So for this, I'm going to rewrite it so that we say sine theta is equal to negative 2 over 5, and all I did was move that negative and moved it to the numerator. And to interpret that, well, the 2, negative 2, is the y, and my 5 is my radius. And to interpret that, that means that we have a negative y, which means we have a terminal arm. We have a terminal arm or two terminal arms that's below the origin. We know that we're dealing with that scenario. So now let's try to predict how many answers are there for theta. The x and y axis. And sometimes I like to write the quadrants. So for now, I wrote my quadrants and the cast. And cast is telling me that my sine is positive over here, but negative on the bottom. Because we're dealing with two negative values for the answer to the primary trig ratio, I'm going to draw two terminal arms here because there's going to be two angles where this is true. Here to here, and another arm that goes all the way around. Okay, and in the next few questions, we'll deal with how we actually find the value. And so we have theta 1 and theta 2. And skip to C. Find all possible measures of theta in the given domain. So this is what your first step is going to be. You're going to try to find the related acute angle, and that is found by doing sine inverse of both sides and finding the theta. I'm going to find theta of the related acute angle by doing sine inverse of the positive version of what we have. Part of that is to ensure that I have a acute angle every single time, and rather than an obtuse, okay? But we do consider the negative later on. This part means related acute angle. So when I put that in the calculator, I will get 24 degrees, and that is part of my rough work. Next, I'm going to go on to the second step. So because that part was my rough work, and now this is my official step 1 related acute angle, y-axis, and we already know that it's in these quadrants based on our drawing before. And so based on my rough work, I know that my related acute angles are 24 degrees. You might, when you arrive at your final answer, all you might have is the rough work and your step 2. But I kind of wanted to show you what is going on step by step, so that you know what the thinking process is and what you have written down first rather than you having only the last picture in your notes. So basically, we already know that this much information, and the last part is to interpret it. And so from here to here, that is your first angle. And so what is my angle going to be? Well, I basically need to do 180 plus 224. Which is equal to 204 degrees. And that's my theta 1. For my theta 2, well, this full circle is 360, but I'm not quite going the full circle. I'm doing 360 degrees minus 24 degrees to find my theta 2. So theta 2 is equal to 360 minus 24. So theta 2 is equal to 336 degrees. And so in terms of your notes, it's fine if you just have this step, this part, and this part. And remember that we needed to drop all the negatives, but I still needed to consider the negative when I was doing this drawing. But in the previous part A, I already interpreted that it is going to be in quadrant 3 and 4 because my value for trig ratio was negative. Question 6. So I have an x value of -2 and a y value of 6. This is my x and y axis, and I have a coordinate around there because it's at -2 and y of 6. So maybe around there. So that means when I'm drawing my principal angle, this is my principal angle. And so it says sketch the angle theta in standard position. I'm done that question. It says find cot theta equals. Well, cot theta is equal to 1 over tan theta. And tan theta is just y over x. So now I have to think of the reciprocal. So it's equal to x over y. And when I plug things in, I have an x value of -2 and a y value of 6. And therefore, that's equal to -1 over 3. It's kind of bad format because right now I'm crammed in space. You should write it so that you're actually going down vertically if given that you have space. And I should write cot theta is equal to -1 over 3. Find the angle. So if I have that cot theta is equal to -1 over 3, that means I have to do the reciprocal. And that means tan theta is equal to -3 over 1. In order to get my tan by itself, I need to do inverse of both sides. So tan inverse of both sides is equal to, well, theta is now equal to, using your calculator, 72 degrees. Keep in mind when you're doing this, you're actually finding the related acute angle and not the actual angle. And so I'm going to indicate that this is actually my rough work. It's not my actual answer because I'm just finding the related acute angle. Because if you look here, that is definitely not 72 degrees. But what that 72 degrees tells me is that that is the related acute angle is what my calculator is letting me know of. And so from there, I'm going to use the picture. So from picture, based on the picture, what is my theta actually equal to? Well, if you try to interpret it, if this is 72 degrees, that means my theta is equal to 180 minus 72. And therefore, theta is actually equal to 108 degrees.